Hello and welcome to Embedded. I cannot believe it has been 3 years since we sat down with James Grenning to talk about this test-driven development concept. This podcast wasn't even called Embedded yet. There were a lot of good things in that show, so we're going to replay it this week. Note that there won't be a Patreon for this episode, though we are quite pleased that so many of you have opted to support the show. If you're looking for a fresh podcast involving me, check out this week's Don't Panic Geocast, where they made me do the lightning round, which I was pretty terrible at. The rest of the show rocked. Pun intended. I would like also to remind you that the SparkFun TinkerKit contest will be over on Friday, December 9th. That's very soon. Email show@embedded.fm or hit the contact link. Please tell me what you'd use it for. And last week we talked about a get-together here in Santa Cruz, Aptos area. That's shaping up for the last weekend in January or first in February. We still don't have a plan other than canapes, but if you're interested, drop me a line so we can start narrowing down our options. Again, show@embedded.fm or hit the contact link on embedded.fm. Okay, enough of that. Let's listen to James. This is Making Embedded Systems, the show for people who love gadgets. I am Alicia White, and today I will be speaking with James Grenning, author of Test-Driven Development for Embedded C. Hi, James. Welcome to the show.
Hi, Al. How you doing?
Great. A little tired, but great.
Me too.
James has let me audit a few days of his course as he teaches the benefits and methodologies of test-driven development. So if I mention the class, that's what we're talking about. And if we mention being tired, that's what we're talking about. And I'm a big believer, I have been for a long time, in design for testability. Our philosophies are a little different, though. I'm going to believe that the listeners of the show already have some sort of testing is good idea. But before we get, the chorus of agreements to go, let's get your baseline. If we met at Embedded Systems Conference, how would you describe yourself and what you teach?
Well, let's see. How would I describe myself and what do I teach? Well, I teach a few things around agile development, test-driven development, engineering practices of test-driven of agile, as well as some of the management practices. So I teach those things. I've been an engineer since the late 70s doing computer software and related type work, management, etc. And so I would describe myself like that, I guess. Maybe not. It's weird to be talking into a microphone, but I'll probably get over that in a little while.
Yeah, you'll get used to it. And if you listening are interested in a class, James is very eloquent when he doesn't have a microphone directly in front of him, and they're big microphones. Check out his Renaissance software. We're also going to be giving away a signed copy of his book. We're going to try the whole contest route here. Clues for how to get the book will be noted as often as I remember them. But first, James is going to choose a number between 0 and 99, because we are zero-based here. And you need to be the first one to guess the number. I'm going to send it via Twitter or the contact link on embedded.fm. It's one entry per person, although in the event of a tie, whoever has the better story about test-driven development events, a stupid thing that happened that got fixed, I don't know. Whoever has a better story always wins. Okay. So you mentioned Agile. Are test-driven development and Agile linked?
They are connected, although test-driven development doesn't have to be used with Agile. But test-driven development, when I learned it, came from extreme programming. Extreme programming predates Agile, as extreme programming and Scrum were things that were known, and being developed during the 90s. I discovered extreme programming in 1999, and Agile didn't happen, I think, until 2001.
We had a show with Curtis Cole that was very Agile is great, but he wasn't interested in test-driven development. I mean, he was interested, but he wasn't an evangelist for it. I am still unclear as to how they can be separate. Do you always teach TDD with Agile, or are they separate?
Well, if a organization comes to me and they want help with Agile, what I'll advise them is that what they need is sound technical practices to go along with the iterative management style. And what I would do is encourage them to first let me teach their engineers what TDD is and what the engineering practices are. And then we would begin shortly thereafter with trying to learn how to get the iterative cycle started. So we do a workshop to help people get stories and their backlog in order.
And you mentioned extreme programming. Is that the same as pair programming, or are they different?
Extreme programming is based on Kent Beck's work, his book published in 1999, I believe. And extreme programming describes 12 practices, some of which are management practices and some of which are technical practices, although Kent is a programmer, and so his emphasis is on the technical practices. So when you hear about someone doing Scrum, Scrum is mostly the management practices. Extreme programming is mostly the engineering practices. And bringing those two things together is a good fit.
And Agile is something that came a little later that definitely has Scrums.
Well, so Agile is kind of a unifying idea of what some of these different techniques were that were evolving in the 90s. So extreme programming involves these 12 practices and iterative development. Scrum involves iterative development and kind of continuous improvement. The developers of Scrum expected that as people would iterate, they would discover, gee, this retesting is not working. We need to do something different. We're going to have to solve the technical problems of incremental delivery, and that means automation of tests and other type things is what Ken Schwaber and company thought would happen, although most Scrum adoptions and Agile adoptions really are light on the engineering practices. And this company's getting into trouble because of this.
Yeah, I hear about Agile. You get a story, you solve some bugs, there's some points, and you don't always hear about how testing. And you said retesting. We talked a little bit in class about that a lot of the benefit for TDD comes from this retesting concept.
It's certainly one of the benefits. When we do test-driven development, there's some misconceptions about what it is. Some people think that let's go write all the tests for the system and then go develop the system. That's going to result in a lot of problems because we'll be making mistakes. Test-driven development is you make mistakes in the upfront work on the test. Test-driven development is an incremental approach. Write a small test, make it work. Write a small test, make it work. So we cycle through a series of we're doing small cycles to try to get the code to do what we want it to do, one behavior at a time.
Yeah, in class, that was the hardest part for me, is that when you say one behavior at a time, you really mean it. Write down the function. I'm in my test. I'm starting from very scratch, and we did a circular buffer, and you wanted me to have init, and I would type in my initialize function name, and then the goal was to compile and to have it fail compiling, and then to go to a header file and put in my initialization API, just that function, nothing more, not the whole API, even though I might have it in mind, just one line at a time. Let it fail a link, and then go and actually implement initialize as a blank function, and then that would pass a test. It was very, very slow to me. Although, as the class went on, it got faster. Is that what you usually find?
It feels slow because it's so foreign, and people are used to what they're used to, and when they're doing something that's foreign, it feels very odd. One of the things that I've realized from doing test-driven development is that I make mistakes quite often. And if I'm going to do these small cycles, I can discover the mistakes right away And if I've only made small changes, then I know exactly where the mistake is. So you mentioned that compile step and the linker failure. If I make code that's incompatible, I get unexpected errors, and I can fix those right away. If I've only got one problem that I'm solving at a time, it's much easier to solve it. So the problem of doing test-driven development is to come up with a series of these tests that when you're finished with all your tests, that you're finished with your production code. And then the question you asked me a second ago was, so you get these tests to get the cost of retest low. As a side effect of getting the system working the first time with the tests, you also leave behind a trail of automated tests that you can continually run in the future as you do other maintenance activities on the code that you've built.
Yeah, you showed a graph in class where if you have, you have a certain number of hours a week and you make a certain amount of features. So every week, let's say you do 3 small features, 3 large features, whatever it is, but a certain amount of stuff gets done. Maybe you measure it in lines of code or files written or some other metric, but we're not going to care about the metric. It's some constant amount of good stuff gets done. And then there's got to be some testing that is associated with the good stuff. And week 1, maybe it's 75% code and 25% test. Week 2, well, now you want to have that same ratio, except when you check in week 2's progress, week 2's new features, another 1,000 lines of code or whatever, you still have to go back and test at least partially week 1 because you might have broken stuff. This is the nature of regression tests.
Right.
And therefore, by week 3, now you have to test week 1 and 2, or you have to live with there being untested code. And so there was this constant amount of work you were doing and this ever-growing linear, I thought exponential, but ever-growing amount of stuff you have to test as you add more code. And you said retesting.
Yeah.
And that's where TDD becomes one of those things you can actually convince people to do, is automated retesting.
Yeah, so even if you didn't do test-driven, if you did test second, you could automate tests and make the cost of retest come down somewhat. One of the driving factors is if what I rely on is manual testing and my intuition on what I should test, I'm going to build up a large backlog of hidden defects and things that aren't going to work in the future. And I might not discover that until much later in the development effort, and then I've got a big bug fix activity that's going to have to happen. This seems to happen in a lot of areas where we build up these bugs and they all appear at the end of the project by surprise. Everyone's surprised. We'd prefer to be proactive. So it feels like doing TDD is slow because you're working on a test and then you're working on production code, you're working on a test, you're working on production code. And it feels slow because it's not what you're used to. It turns out, if we think about the time we spend, not just writing the production code, but the time we spend writing the production code and testing it and fixing the bugs, we're probably even with the time to test drive that code the first time in a proactive way, maybe even ahead of the game. So if those two costs are similar, if we go look at the future, the next time we have to touch that code, the retest is virtually zero, okay, because we have the automated tests that we can run.
And who hasn't had to go back and make a change after you thought you were done?
I think probably none of our listeners tonight.
Yeah. I mean, even the Mars rovers are firmware updatable. So you have to go back and test. But test-driven development is something I have a few questions about because I prefer test-driven design. And maybe this was something I picked up working with the hardware engineers, where it's designed for test. There was a big acronym and designed for manufacturability. You have to design a board so that later you can verify that it works. And you can then point your finger at the software engineer and say, no, my part works. Not that that ever happens. Hi, Phil. But that was my introduction to it, is this idea that every piece of the system, mechanical, software, hardware, they all have to be designed so that at some point you can point to it and say, that works. And I can show you, here is why I think it works. And, it's never irrefutable. Maybe it works only when the sun is shining sort of problem. But it's a design ideal. You don't go into a problem without thinking how you're going to prove that you've solved it. I think it's kind of a scientific method sort of thing. You have to have an end. You have to have a hypothesis, and then you either get there or you don't. And
you mean TDD is a scientific method thing, or design for test is a scientific method thing? Design
for test more, and test-driven development helps me get there because I do have to design the tests. But it's a very programming sort of exercise. It's not a systems architecture sort of exercise. Does that make sense? Or do you disagree?
I can understand your point. So design for testability is a nice thing, but if it's not tested, who cares? So
it's true.
Okay, so with test-driven, it will be tested, and it will be testable. How can I prove it? I've got the tests, okay? I'm kind of stealing this from Ron Jeffries because there was a conversation over Twitter a few months ago, which is around this topic of testable, prove it. Testable doesn't matter. Tested is what matters. And test-driven, now if you say test-driven design or test-driven development, you'll find that TDD, that term is used both ways.
Oh.
In 1999, when you would have picked up the Extreme Programming book, it would have said test-first programming. Over time, we've evolved the name and understood better the impact that test driving your code has on design. For instance, where modularity might not matter if you were just manually testing your code only in the target system later, modularity might not matter so much. But if my goal is to be able to write tests for each module of my code, if I get a module that's out of control, too much complexity in it, I won't be able to test it. And it'll be too late. That thing will only be manually testable. If I'm test driving, I'll discover that early. I'll get an early warning that there's a problem with my design because I can't get to the code that I would like to add. I can't think of a way to test it. It means the module is too big and needs to be split apart. So test-driven development incorporates test-driven design.
I did notice in class that the modules we worked on were very well modularized. And that was because if you wanted to replace the I/O driver for the flash interface, you had to separate out the I/O driver. I mean, if it was going to be SPI or whatever, there was a hard line there because that's where you were sneaking out the code and putting in a mock or a fake or a pineapple or whatever you called it.
A SPI, a test double.
A test double.
A pineapple?
Oh, I had a tweet.
You must have been thinking about lunch.
No, that was the exploding fakes you mentioned. That if you put them in, then if you ever get there, they explode. Yeah. And it made me think about grenades, which made me think about pineapples. And yeah, maybe it was about 3:00.
Okay. Time for a quickie.
But the test doubles force you to think about where you can cut things apart. And that helps with the modularity. And also, if you are trying to design tests for something, as well as the code, it kind of decreases the amount of brain space you have, which means that you try to minimize the problem into the right chunk. And I liked that. I liked that a lot. I didn't expect test-driven development to drive modularity to that extent. Yeah, and I hope that wasn't just an artifact of having good examples.
Well, I also have other schooling in my background, which is the Bob Martin School of Solid Design. Bob Martin some of the listeners might know of Bob. He's influential with Agile, test-driven development, object-oriented design, and the person that coined the phrase solid design principles, which there's 5 different principles, one for each letter. And these principles are guiding in when we make a design decision, we want to use these principles. For instance, one of them is single responsibility, the S in solid. It says a module should have a single responsibility. It seems kind of like an obvious thing, but you know what? All the code I see in the world, almost no one does this. They've got lots of mixed up and confused responsibilities. So I try to, with my code, show what could be and how we could make modules that actually obey these principles.
And so that goes back into, you teach more than the test-driven development class. You teach Agile classes and whole system design courses.
Coaching in that more. But I used to teach design.
All right.
I don't do much of it now, though.
Is your number 42?
Is my number 42? It is not.
All right. Okay. See,
Am I supposed to tell you if it is?
You're not supposed to lie to me.
I thought I was going to pick the number afterwards.
No, you're supposed to pick the number. You were supposed to pick it when I gave the spiel at the beginning. That was all the time.
All right, I'll work on it.
Okay, maybe now that we know it's not 42, we should choose a number. There'll be a few more questions.
All right. Okay.
As Christopher pointed out earlier before we started recording, I'm tricking people into listening to the whole podcast. Oh, good. James is going to write down the number. That will help me.
You don't get to see it, though.
You shouldn't have used a Sharpie then.
Did you see it?
No. Okay, so sorry. Sorry for those of you I'm tricking into listening to the whole podcast so you can get a signed copy of Test-Driven Development for Embedded C. But, keep listening. Let's see. What do you prefer to teach? Everything or just TDD?
So I prefer the engineering practices, which TDD is essentially the center of the engineering practices. There's more to it than just the TDD part. So that's kind of my mission, is to help engineers to learn these techniques, because in 1999, when I was sitting through the extreme programming immersion that I was invited to, taught by Kent Beck and Ron Jeffries and Martin Fowler and Bob Martin, test-driven development was demonstrated to me in Java. So I know a number of languages, including Java and C++, as well as my embedded C. And they were demonstrating test-driven development, and they had dependencies on things that they wanted to fake out. And as this was demonstrated to me, it became obvious that this is a solution to a problem embedded engineers have. And the problem embedded engineers have is they're often doing their work without anything to run their code on. The target system is not going to be ready. They're doing concurrent hardware, software development. Many times in my career, we had to wait, and late in the development cycle, we'd get hardware and then find out none of our code works. When I saw test-driven development demonstrated, the idea to me was, for embedded code, we could do this and get good confidence built in our code before we ever have the hardware. When the hardware comes, we can find out if it integrates, and hopefully we'll have less problems and we can move to the market quicker, rather than having all the unknown of all this unworking code when we first get our first board. And that was really important.
But when I'm running on a small processor, you want me to run my code on a PC?
You're writing in C, okay?
Well, as close to C as I can get with
your
1980s based development environment, which I'm telling you, Christopher is saving up a rant on that one. But
you might want to update the old Intel Blue Box.
It's not that. It's not that. It's just, but embedded compilers are a little hokey sometimes.
Sure.
And there are chip-to-chip differences.
Yeah, so let me say a couple things about that. So C is supposed to be portable, right?
It is.
Supposed to be, quote unquote, portable language. But then compiler manufacturers start putting in special help for you, like they make global variables that are their registers. They make special keywords to say this function is actually hooked up to interrupt number 1. They extend C, right?
Exactly. That's what I mean.
Yeah. Okay. Well, that's too bad they're doing that. This causes a big problem because now this code can only be run with their compiler and their processor. It kind of makes me wonder. Now, I assume first good intent. They're trying to help you build a better system. But I also wonder if they're not trying to handcuff you to their tools and their silicon also. Because pretty much if you use any of those special things, you're locked into their stuff without having to do major changes. I have a little snippet of code up on my GitHub account, J.W. Grenning. Up on my GitHub account, it's called the Legacy Code Challenge. And if you want to go grab that and see if you can convince that code to get into a unit test harness, it would be interesting off of whatever target that might be. I forget what it's for. But I do encourage people to get their code off the target because that's a huge bottleneck. If I write code for something I don't have hardware for, how can I get my work done? Well, I can wait. Okay. If I can't fit any tests into my constrained memory, how do I test it? I can manually test it. Maybe that's okay for a small application, but for anything bigger, it's not. So I encourage people to get their code portable. Try to isolate as much of their code from the hardware so it can be tested in a friendlier environment. There's kind of a nice side effect of this too, is when that hardware goes obsolete, which it's going to, right? How do I know this?
It always does.
There's Moore's Law, right? It's going to keep changing. Then maybe the bulk of their intellectual property can move without major change if it's not tied to this silicon vendor's specific code.
And voila, we are back to modularity.
Absolutely. Managing of dependencies. This is one of the lessons I learned from Uncle Bob.
That's Bob Martin, right?
Yeah, that's right.
So are we going to end up with a processor simulator? How are we going to get away from recreating the whole hardware in software?
Well, we're going to write portable code, okay, for starters, and we're going to fake out our dependencies on the hardware. So, like we did in the class today, we wrote a flash driver that interacted with a memory map device. We had to intercept the calls to two functions, IO write and IO read. And we could put this thing we call a mock object behind it. And the mock object, I would call it a simulator, but it's not really a simulator. It's much simpler than a simulator. Because if I'm going to simulate a flash device, it's probably going to be more complicated than the code I need to write to drive the flash. So I'm not going to write a simulator, but I can simulate a sequence of interactions with the flash device. And so this mock version, this fake version of IO read and IO write, enable me to surround the code I'm working on and thoroughly test it. I can go right from the design spec for the part, the flowcharts, and write code that meets those flowcharts to the best of my ability, get that to work. And then when I get the hardware, I marry these things two together and find out where I messed up. Okay?
And now you have 10% of the bugs you would have had if you hadn't done any of this. If you'd just written the code, you'd have had a whole bunch of bugs. But now we're at the oddity, the I misread the data sheet sort of bugs.
Yeah.
And that's a much smaller subset of all the possible ones.
Yeah, and whether it's 10% or 10 or 2, I don't know what that is, but it's much less than the number of mistakes that you would normally make. I mean, people are really good at making mistakes. I used to think I was good at programming, and so until I started doing test-driven development, then I discovered that I make about, I don't know, you were measuring me this week, about 10 per hour, or am I being kind to myself now? I know some of them I made them on purpose, but most of them were live, not Memorex.
Well, the thing about test-driven development is that the mistakes, they're different. If I let a bug out into the world, that's a bug, and it annoys me. It annoys me if a customer calls and says, this is broken. I have one client that they accuse that the customer is vocal and ends up on boards, like forums and stuff, and complains and about how the device doesn't do this special nifty feature that was all promised. And I spent time looking at the bug, and I realized it was a server problem, and it kills me that 6 months later, the server problem hasn't been fixed, and the customers are still saying the device is broken. And so that is a bug. That's a real bug. And even the bug that makes it to QA, or even the bug that makes it to my colleagues who have slowed them down, those are bugs. But when it's just me tippy typing, if it's just me and the compiler, I don't really call those bugs. I'm not even sure I call them mistakes. They're just, this is what I do all day. I type, I pound on my keyboard back and forth. And
well, actually, most of the time you're thinking.
Yes.
So most programming is thinking. And it's not about typing. Having good typing skills is certainly helpful. But thinking, you have to have good, clear thinking skills. And TDD helps us express what we want. So the tests express what we want, and then we make the production code do it. If you write code and you make a mistake, I don't know, for me, conditional logic, actually for a lot of people, conditional logic is quite difficult to get right the first time. And the tests just help me get it done quicker, because I can get feedback immediately while I'm thinking about it. You were asking me a couple of minutes ago, though, about
abstraction layers and test doubles and processors.
I'm thinking of something else. I'm just kind of gathering my thoughts here. I do get stories back from people that have taken my class. And one gal who's an embedded engineer down in Texas, she sent me an email telling her story. She said, well, I thought it was all kind of crazy, this whole test-driven thing, but I thought I'll give it a try because I don't have the hardware anyway. All I've got are the specs. So she worked for a couple months on her application and her interface to the hardware, et cetera, and then finally got aboard. And in her story, she told me that there were 3 changes she had to make, that she had misunderstood what the spec did. And then she was done. And she said, it's the first time I've ever been finished early. She was 2 months early in her deliverable. Time that would have been spent grueling, going through all the code line by line, trying to find out what's working, what isn't working. She spent several days in integration, and then everything worked, and she was done early. It was a really nice email to get.
Yeah, that's excellent.
I get these from time to time.
Yeah, that's got to make teaching nice.
Yeah. Well, when you hear that someone has success with these crazy ideas, it's really helpful.
So how did you get into teaching? You were an engineer.
Yeah. I still, if someone asks me what I am, I'm an engineer. I can't stop being an engineer. I think I was one before I ever went to school, too, because engineering is about problem solving, and I've always done that.
It's kind of been a theme on the show, is me trying to figure out how people identify themselves. Mm-hmm. Because you and I have both written books, but I bet, have you ever introduced yourself as an author?
No. I'd introduce myself as an engineer that happened to write a book. Yeah. Or that happens to teach people.
But I've met people who introduce themselves as authors who have never had a published book. And yet that's how they see themselves. They are authors, writers. Yeah. It's really cool, but I'm an engineer. I agree with you.
Yeah.
So you don't introduce yourself as a teacher?
No.
Or instructor? Or
No, I say I teach, but I'm an engineer.
Okay, so you were an engineer.
Yep.
And you wrote a book.
Yep.
And then you started teaching?
No.
You were an engineer and then a consultant and then a teacher and then a book writer?
I'm not sure.
Really?
No.
This is your career. I'm not sure I can fill this in.
What I'm not sure about is that it's a long day, and you just did about a 5 combination thing, and I'm not sure what you asked me.
No, I'm sorry. Tell me about your career.
All right. So in high school in the 70s, a friend of mine was programming a computer at our high school. I said that part already. And he showed me his computer listings and his punch cards. And I thought, that looks horrible. I'm going to stay away from that. And then he said, no, come and check out the computer lab. And he showed me in, and there's a big, scary guy in there, and there's no windows. And it's like, no, thanks. I'm not going in there.
Definitely no girls.
There were no girls. Well, I actually went to Loyola Academy, which is an all-boys Jesuit high school. So there were no girls around anyway. So it would have been okay to go in the computer lab. But so in college, I'm taking engineering classes, and in calculus, the professor gets this bright idea that we're all going to simulate Newton's method of calculating the area underneath a curve. And we had these teletype machines for doing some basic programming. And he showed us how to do a little bit of programming, and then we had to go figure that out. And so my regretting, getting anywhere near a computer was ending because I had to do this. And it actually wasn't so horrible. Actually, it was quite fun to get to trick the computer into doing something for me, and I liked it.
Get the computer, trick the computer.
Trick the computer into doing something for me. And so I stuck with this math teacher and got more experience at that. And then I picked up an elective, and then there was a required programming class. And then the next thing I was thinking is, people will pay me to do this?
Yes, exactly. This is a scam. People will pay me to do this?
Yeah. It's like, oh, okay, I know what this is my major now. So, it's part of the master plan. No, it just kind of happened. My first job out of college was with a company that did contracts for the FAA. And the day I walk in, my boss gives me a data book with the 8251 in it and said, go figure out how to work this thing. I didn't know what that was. I didn't know what a data book was. And then we built a color weather radar display system with 16K of RAM and 16K of PROM. We did have to upgrade it from 12K. It was the first ever color weather radar for the FAA. It was kind of a cool thing to work on as a young guy. And then I changed to a different job where we started doing C and embedded processors like 8085s, and you can fill an 8085 with C code really fast. So we had to do crazy things like bank switching of memory, and then we got a bigger processor in 8086. And then, so my career was involved in building some cool stuff in the 80s and getting into some leadership and management roles, and then getting kind of fed up with corporate life, and then joining my friend Bob Martin in his consulting business in the mid-90s. I had worked with Bob throughout the 80s at this my second job. And so we consulted together, and that's when I started teaching. Bob kind of taught me how to teach.
Cool.
Yeah.
But that's what you do full-time now?
I do teaching and coaching and consulting.
And then
I do some
projects.
Some writing, and I do projects for me.
Yeah. Cool. How much of what you teach is test-driven development, and how much is just good design practices? Are they separate?
They're not. No, they're not separate. To me, they're not separate. I've seen a lot of people write tests that don't know how to design. I've seen more people that can sling out code that don't know how to design either. I find that the feedback you get from writing tests is very valuable to critiquing your work. If you write code that's not modular, your tests will be a mess. It starts to tell you there's a problem. If you're willing to listen to what the code is saying and the tests are saying, you can come up with better designs. So in my 3-day class, basically the way it works is on the first 2 days, we spend a lot of time going through test-driven development examples and exercises and growing in complexity. And then on the day 3, we get into solid design principles, refactoring techniques. How do we keep a design clean for a long period of time? And then the thing that everybody's been worried about the whole time, in the afternoon, we get into legacy code. I do it this way, legacy code at the end, because I want to paint a picture of what could be, how nice code could be, and how modular and independent it can be with these tests. And then we get into the real world of, well, what's your real code? Okay, so in the last day, we're talking about the techniques for dealing with legacy code. And then the next then the end of the class, either 1 or 2 days, we spend in the attendees' code. They bring their own code because it's hard to go from these simpler ideas in the classroom to their big mess is really what it turns out. Their problem code, I shouldn't call it a big mess. They're successful products doing great things in our world, but usually the code has suffered. And we spend time trying to get their code disentangled from their execution environment and into the test harness so we can start to evolve that code in a safer way with tests.
Because few people start a project from scratch. I mean, usually you are continuing someone's project.
Right.
Very few of us get to write the first line of the code.
Mm-hmm.
So legacy, I think that's important because that's where the rubber meets the road. That's where theory becomes practice.
You're going to write new code too, but you're going to have to make it work with existing code. So you need to know. So the rubber can meet the road in a number of different places. So in the new functionality, totally new functionality can be test-driven, but existing functionality that's going to be evolved needs to be treated carefully. Treated carefully first by adding some tests to it. We can't afford to add tests to everything, so we're kind of strategic about how we add the test to it. And then, being careful, just getting really good at being careful and not introducing unintended consequences.
And then for legacy code, do you treat it like third-party code? Or how do you treat third-party code like APIs and libraries, RTOSs, graphics libraries, board support packages?
Okay, so if I'm starting from scratch, what I would like to do is somehow abstract away a little bit from the thing I'm using. So let's say I'm buying a third-party package to do something. Usually a third-party package, be it a RTOS or a database or some kind of file system or something, usually what we need is something focused, meeting some need of our product, but what the vendor is providing is a general solution that does way more than we need. If I let my code just use directly this third-party code, any piece we need, I'm going to get bound to that thing, and it's going to make my life difficult in the future if I want to change. It's also going to make testing difficult because that thing is probably going to be tied to my hardware or something in my execution environment, my operating system. So what I would prefer would be to write an interface that I own. So if I'm using a third-party operating system, I might slightly abstract the operating system. I might say, how do I get time from the operating system? How do I get a periodic wake-up call from the operating system? I want to have an API that I own that does that, and I'll write a small adapter behind that thing that can interact with the actual third-party operating system to give me those features. That way, if I change my mind when I use a different one, I can limit the amount of work. But the tie-in to this with test-driven development is if I own that interface, I can create fakes for it, and it's more convenient. I can build this interface. This is one of the design principles. This is the interface segregation principle from Solid, which would tell me to design my code to a focused interface that my code needs. Design the interface for the client's need, not for what the server provides. Okay, then you write an adapter in between the two. And this gives you a lot of flexibility as you evolve your system.
That makes sense. And it kind of, okay, I believe in test-driven development. But one of the things that came up in class today, and it was a little hard to answer, was, okay, I'm in. You've convinced me. How do I convince my boss? Or how do I convince my engineers?
Mm-hmm.
How do I convince my boss to let me have the initial ramp-up time? How do I convince my engineers that this isn't going to slow them down? How do you convince people this is a good idea?
Well, I can't convince them really, but what I'll try to do is what I want to know first when I'm working with an organization is, do they recognize that there's problems? And the problems that they usually recognize is that we're late. And part of why we're late is that we're chasing bugs. And, life is not as good as it could be. Okay, this is one of the problems. Now, We talked earlier about the cost of retest. One thing I'd like managers to be aware of is how we can't afford not to automate our tests. If we don't automate our tests, that means after the second week, I have to retest the first and then test the first time the second. After the third week, I get to retest 2 batches. After the fourth week, I'm retesting 4 batches. And I don't really do all that retesting. I stop testing things I should, and I start to accumulate risk, and I think of it as tinder under the forest. Eventually, there'll be a lightning strike, and it's all going to go up. Okay, so I want them to be aware of that problem, because it's a very simple model. I've got an article on my blog about that, and it's called Manual Test is Not Sustainable. So if you're interested in looking at that, take a look at that. It's a very simple model, easy to communicate to people that aren't techies. So I want people to be aware of that. And the other thing in just trying to get people to start it is, when we put off testing till the end, we're going to have a lot of problems at the worst possible time. So we want to try to find a way to get features to be written and work and stay working throughout the life of the product. And that means the cost of retest must be low. That means some automation. So there's those things. And you're asking me, how do I convince people? And I make a point of telling people that I am not really there to convince them. I will try to convince them that I'm convinced, okay, and that I know that this helps me, and try to get them to see what's in it for them so that they will try it and see if they can convince themselves one way or the other. So, for instance, at the beginning, I asked you and the others, what do you like about programming and about development? And I hear about design and about I like to program, I like to solve problems, things like that. And then I ask, well, what don't you like? And people tell me they don't like doing repetitive tasks. They don't like testing. That's usually somebody whose boss made them come to the class. That's my third question. Why are you here? I don't like testing. They think they're going to get at me because I don't like testing either. Because testing, what they're thinking of, manual, repetitive, boring testing is not fun. Test-driven development, on the other hand, happens to be problem solving and coding, things that people like. So I appeal to them, try to move them into doing more things they like. Other things they don't like are writing documents and chasing bugs. And so I challenge people and say, what if we could do less of the things you don't like and more of the things you do like? Would that be interesting to you? Will you try it? And by the way, I'm here to make you try it for 3 days. So you're going to try it.
3 days is not that long in an engineering career.
Yeah, it's not that long. I also encourage, everybody in the class is usually younger than me. So I say, hey, you guys have a lot of your career left. And I learned this after 20 years of experience. I wished I had learned it earlier because it would have saved me a lot of headaches in the 80s and 90s if I had known these things, rather than just at the turn of the century. So it's really not up to me to convince anybody. It's up to me to try to connect the problem that they see, which is I've got defects, it's making me late, it's making me chase bugs, and to a potential solution to that problem. So as an engineer, I like to approach it as a problem and a solution. What's the problem? I've got defects, I've got a bad design, I've got such and such. What's the solution? Well, if we had a feedback loop around our coding that showed us when we made mistakes and we could get them out, if we could discover when we had design problems sooner, we could change those before it's too hard. Do you see how these things connect and how there might be an improvement in your situation? And so I try to appeal to the logic of that problem solving, and then I want them to experience it so they can actually make a decision based on their own experience and not on something I'm saying. Right? So they'll experience it and see if they think it would help them.
That makes sense. It's hard to be an evangelist for something that you barely understand.
Sure. Yeah, and we had a couple guys in the class today who felt their role was to go back and convince their colleagues. And I kind of warned them that that's not their job, and by the way, they won't be able to. Because I've actually tried to do that. Now, after having taught test-driven development now for probably over a decade in one form or another, Java or C++ or C, I realized I can't convince anybody to do it. I can't convince them that it's a good idea, but I can get them to try it. And so they can so they have an opportunity to convince themselves.
That was when we talked about how to convince somebody to use it. My personal idea was a little on the attempted sneaky side, which is,
I always appreciate that approach.
If someone is giving you a hard time because they just hate the idea of it, tell them to learn about it, to understand it, so that they can tell you why it sucks.
Yeah.
And when they come back, either they will say, it sucks and here's why, and then that's a problem and you can talk about it. Or they will say, it may not be the best thing ever. It may not be the solution to all of the world's problems, but it's better than what I had.
Yeah.
And better than what I had is a step, and that is a fantastic step. If you are actually moving forward instead of just to the side, all right, let's keep going that direction. So I kind of liked the well, tell them they have to learn it so they can tell you it sucks. And then,
yeah. Well, the worst time to make a decision about something is when you don't know anything about it. And so
what? Really? I know a number of people that's just not true for.
Oh, well, they're using System 1, I guess, right?
Oh, yes. Ignorance-based decision-making.
Okay.
Yeah. So is test-driven development and Agile the one true path? Is this the only way to do it?
Oh, I doubt that. Is it the best that I know about right now? Yeah. People work better on smaller things and with feedback. So we could look at lots of examples of monumental systems built with a lot of upfront work. We're just going to plan it out and then execute, and they don't. It doesn't work. Incremental development was how software development started. A lot of successful systems were built with incremental development. Agile and TDD are forms of incremental development. We find that people are more successful at that. There's some interesting writings. Craig Larman wrote an interesting article about the history of incremental development, which kind of goes through some of the older systems like Polaris submarines and Atlas rockets and space shuttle that were developed incrementally with a lot of the techniques that we now would call Agile. And then there's other things that were developed later under the 2167A banner of planned and tracked that are disasters. FBI wasting hundreds of millions of dollars on a record system. I don't know if there's something going on in the healthcare industry right now, a big $600 million project that's not working so good. There's these monumental big efforts that don't tend to work out so well. Incremental development is about trying things, getting feedback, seeing if it's what your customer wanted. That's what I like about it. Does it fit everything? I don't know, because I don't know everything. No one's ever accused me of knowing everything either, by the way. So
back to your number. You mentioned System 1, and I'm going to go off the air with a little tidbit from Thinking Fast and Slow, and I'll explain a little bit of that. But one of the things that this book about psychology that you and I have been talking about is about grounding and some human factors. It says that if you ask someone to choose a number between 1 and 10, due to just how our brains work, the number is usually 7. Is your number 7?
It is not.
Okay.
Right. But you asked me to pick a number between 1 and 100, I think, right?
No. I don't think it was 1 and 100.
No? 0 and 100.
0 and 99. We're zero-based here.
Oh, okay. Zero-based. Okay.
It's an embedded systems show.
Yeah, that would be better. Why wouldn't you go up to something more sensible like
255?
100 hex? I don't know.
All right.
Yeah, can my answer be in hex?
Yes.
Okay.
New rule. Your answer can be in hex.
I'm going to have to change my number then.
But it's still not...
No, I'll leave the number. Okay, never mind.
All right. Well, I actually have more questions for you, but I think I'm about out of time. I have all these questions about, well, what about this kind of test? Does it count? Does that count? Manufacturing test, hardware in the loop test, sandboxes, online, offline. But I'm tired, and I think maybe it's time to set you free, and we'll gather some questions and do this again in a couple months. Does that sound okay to you?
Sure.
Do you have any last thoughts you'd like to leave us with?
Let's see. Any last thoughts? I had some a while ago, but, being what time it is now of the night and the long day.
And the beer.
Well, there's only one beer here, but we could probably solve that problem.
Yes.
I also like to, if you know about the Untapped website.
No.
The Untapped app. UNTAPPD. It's the beer drinkers' Twitter. So my handle on that is JW Grenning too, and I have some beer drinkers from around the world that will toast me from time to time. That's kind of a fun one. So if you're listening to this podcast, shoot me a message and we could be Untapped friends.
My guest has been James Grenning. Thank you so much for joining me.
Thanks for having me. Wonderful to be with you tonight, Al.
Links will be in the show notes if you want to contact James via Twitter or via Untapped, the beer app. If you have comments for James and can limit yourself to 140 characters, Twitter's great. It's at JW Grenning, and that will be in the show notes. Otherwise, send an email via the contact link on embedded.fm, and I'll make sure it gets to the right place. That is also how you will be getting your signed copy of Test-Driven Development for Embedded C. Send me a number, and I'm sure James is going to leave me his number, and we'll take whoever's first. Hopefully I will announce it next week. This week's last little tidbit is from the book Thinking Fast and Slow, since James and I have been talking about it both offline and online. It has to do with what System 1 is and how that all works. It is a great, if huge, book, all about how to manipulate your brain and other people's brains. Please use what you learned for good. Here's one of the things I learned. When faced with a difficult situation, we often answer an easier one instead, usually without noticing the substitution. What does that say about your code? Embedded is an independently produced radio show that focuses on the many aspects of engineering. It is a production of Logical Elegance, an embedded software consulting company in California. If there are advertisements in the show, we did not put them there and do not receive money from them. At this time, our sponsors are Logical Elegance and listeners like you.